This is Algebra 2, Lesson 8-5, Factoring by Grouping. Our objective today is to factor cubic polynomials with four terms using the grouping strategy. I just want to show you three examples, and I think you'll be able to pick it up from there. The general idea here is we split up the problem into two pieces. So I'm going to put this, actually I have dashed lines now. I can separate it into two different parts, and I can say, okay, the first half of this equation is just this 15x to the power 3 minus 9x squared, etc. I'm going to ignore you for a second, the right side. The left side, what is the greatest common factor of the left side? I noticed that I can factor out some x's. In fact, the x squared is probably the one I'm going to factor out. So I'm going to say factor out, well, I want to not use a dashed line now. I want to factor out an x squared from each of these. If I factor out an x squared, I can also factor out a coefficient. 9 and 15 have 3 in common, so I can factor out 3x squared from each of these. So let's factor out that 3x squared. What's left over? Let's see. This 15 divided by 3 is 5, and left over x to the power 3 divided by x to the power 2. There's just one copy of x left, so it's going to be 5x, and then I'm going to say minus, and then what do we have over here? Over here we have 9 divided by 3 is 3, and then I have x squared and x squared. They're the same thing, so these just cross each other off, and I have factored out the greatest common factor. Okay, I'm going to glue, and I'm putting that in like air quotes right now. I'm going to glue this piece together with this piece right here. So I'm going to say I'm going to glue this piece with this other piece. And I'm going to also factor out the greatest common factor here. So I'm going to say, okay, the greatest common factor over here is going to be, let's see, I can divide this one by, I can't divide both of them by x because this one doesn't even have an x. So I just have to do a number here, a coefficient. I'm thinking 2. Maybe I can do even bigger than that. Maybe I can do 4. If I do 4, this one turns into a 3. I think 4 is the biggest I can do. So let's go ahead and factor out a 4. If I factor out a 4 and factor out a 4, what's left over? So I'm factoring out a 4, and everything that's left over, I can do that in a different color. I have negative 20x divided by 4 is a negative 5x, negative 5x. And then I have 12 divided by 4, which is just a positive 3. So I'll say plus 3. And this problem I purposely made a little bit tricky to show you this. Notice how similar this term here and this term here are. They are really, really close to each other. If only I could make this a positive and this negative, then I could have the same exact factor of 5x minus 3. You can do that. Watch me do it right here. I'm going to take this negative out. I'm really going to divide by a negative 4 on each of these. Watch what happens when I do that. This plus sign is going to be, I guess I can leave it as a plus sign, can't I? I can add a negative 4, and if I do a negative divided by negative, this turns into a positive. And if I do a positive divided by negative, that turns into a negative. And check it out. I have a 5x minus 3 and a 5x minus 3. What we have set up is a group of 5x minus 3 and another group of 5x minus 3s. So I don't like calling this thing 5x minus 3s. I like calling this thing just a unit. It's an apple, if you will. So imagine this thing as I'm going to be a terrible person at drawing an apple. There's my apple. This, I'm saying I have 3 apples and I have 4 apples. I have a total of 3 plus 4 apples, or a total of 7 apples. I know that that metaphor doesn't work very well, but it's just counting. This is the quantity of this thing. This is another quantity of this thing. The total number is these two quantities added together of this thing. That's my way of explaining it, but it still doesn't make sense, and I apologize for that. But the final answer here is 3x squared minus 4 copies. This is the number of copies of this 5x minus 3. I guess I could make that end parentheses in black to make it my final answer. That's it. We are now done with the problem. I know a lot of students at this step are like, what? Like, how did you get from 5x? There were 2 of those 5x minus 3s. How did you get to one of them? It's counting, right? It's counting this number. And okay, let me make another problem that maybe can help some students. What if I told you we had 3 apples and I wanted to add that with another 2 apples? What I would have is I have a total of 3 plus 2 of those apples. what I've done here is I've taken two things and I've turned it into one thing. And again, this does turn into 5 apples because I happen to have like terms, 3 and 3 here. Sorry, I want to do that in highlighter, not laser pointer. 3 plus 2 is 5, so I can combine that. Over here, I can't combine the 3x squared and minus 4 because they aren't like terms, but I did turn two things into one thing, just the same way I've done over here. Two things have turned into one thing. This is just talking about the quantity of that 5x minus 3. I know there will be confusion, but this process that I've done over and over will work. Again, just make sure that this and this are the same number to make groups. That this is 3x squared groups of 5x minus 3. This is minus 4 groups of 5x minus 3. Count the total number of groups of that 5x minus 3. Let's see another example and see how it works. Again, the general idea here is we split our problem in two. We say, okay, right there, there's our problem, and I'm going to factor out the greatest common factor of the first one. Okay, for these, I can factor out an x to the power of 3. And, ooh, I have to be careful here. I forgot my first step, or step 0 in my last problem. Luckily, I got away with it. Technically, even before I separate the problem into two, all 4 of these terms have a greatest common factor. Back up here, if I have 15, 9, 20, and 12, 20 cannot be divided by 3. All of these numbers can be divided by 3. None of these numbers can be divided, these numbers can be divided by x, but this one doesn't have an x. There were no greatest common factors for all 4 of these terms if I consider them all as a single problem. For these 4 terms, there is now a greatest common factor. I have to be careful here. So the first greatest common factor, I can divide each of these by a number. Can you figure out what that number is? Well, first of all of them have an x. Therefore, I can divide each of them by an x. Additionally, there's a number out front I can divide each of these by, and it might not seem super obvious at first until I tell you a trick for checking for divisibility by 3. Add the digits. 2 plus 1 adds up to 3, therefore this number is divisible by 3 because 3 is divisible by 3. 2 plus 4 is 6, therefore 24 is divisible by 3 because 6 is divisible by 3. 1 plus 0 plus 5 is 6, which is divisible by 3, therefore this is divisible by 3. And 1 plus 2 plus 0 is 3, therefore this number is also divisible by 3. All of these are divisible by 3. Which means 3x is the greatest common factor of all 4 of those terms. What is left over is a 7x to the power of 3 minus an 8x to the power of 2 plus, I have to be careful here, I know that if I do 99, that will give me 99 divided by 3 is the same thing as 33, and then I need another 6, which is divided by 3, so I need another 2, and that's going to be 35. X in this case, because I have x to the power of 2, subtract the 1, and then 12 divided by 3 here is 4, and then add on the 0 is 40, so this is going to be minus 40, and we have factored out the greatest common factor of all 4 of those terms, which can be a daunting task if you do not have a calculator. For you guys, you have your multiplication tables. Okay, now that we factored out the greatest common factor of all 4 of these terms, then I apply that grouping method where I split this problem down the center and say, okay, now there's 2 pieces. Let's go ahead and find the greatest common factor of the first piece. What color should we use here? Let's use light green. What can I divide each of these evenly by? And by the way, a good clue to know that you have to do a greatest common factor, just always do it, but sometimes if you have x to the power of 4, the definition up here, or the objective was to factor cubics, and this one wasn't even a cubic, it's a quartic. All right, anyway, this one can be divided by an x squared for sure. And 7 and 8 are co-prime, meaning I can't divide them by anything else, meaning I have x squared being factored out. What's left over is a 7x and a minus 8. Don't forget that original 3x that's still out here, but that's going to matter at the very end. Let me put the 3x. There we go. I'm going to put 3x right here, giant brackets. Just kind of forget about the 3x until the very end. All right, next, what do we have? We have plus, and we've got some things going on over here. What can I factor out on each of these? I can divide each of those by, okay, I can't divide them by an x, there's no x here. I can divide each of these by 5. So I'm going to go ahead and say divide by 5, which means 5 is factored out. What's left over when I factor out 5? Well, if I do 35x divided by 5, I get 7x, so 7x, and negative 4 divided by 5 is negative 8. And check it out, we didn't even have to change this one. 7x minus 8 is the same as 7x minus 8, therefore I have my groupings correct. By the way, I do need to close my end bracket here, so I'm going to close that over here and say my end bracket is closed, and I'm going to rewrite that pesky 3x out front and say, okay, how many copies of this 7x minus 8 do I have? So I'm going to write my 7x minus 8. I'm going from 2 copies of 7x minus 8 into 1 copy of 7x minus 8. And how many do I have? I have x squared plus 5 of those terms. So I have a total of, and I'll write this over here, I have a total of x squared plus 5 of those 7x minus 8s. And here is the final answer. We can go ahead and box it. All right, I just want to give a word of warning. While this one was a truly hard problem, I can make it even harder. What if this number could be factored? It can't, because this is a sum and there's a square. But what if this was a difference of squares? Let me show you the hardest type of problem I can throw your way in example number 3. So example number 3, the first thing that I see is, okay, it's a cubic, which means I can't divide each one by x. Is there a greatest common factor? Ooh, 5, 0, 0, 0. Okay, I can divide each of these by 5. So that should have been your first step. You're going to say, okay, each of these has a number that we can divide by. We can divide each of them by the greatest common factor. 5, 5, 5, and 5. When we do that, we're left over with, let's see, so can I show you the trick for dividing by 5? Get rid of a 0 and then double. It's kind of nice, right? So get rid of that and double, I get 24. Get rid of a 0, double, that turns into 20. So I'm going to come back with, I guess I'll do the x cubed now. X cubed, x squared. All right, get rid of a 0 and then double. That double 3 turns into a 6, so minus 6x. And getting rid of a 0 doesn't work in this case, but watch this. Getting rid of 0 means really moving the decimal place, which is 2.5. 2.5 doubled is 5, which is kind of silly because I know 25 divided by 5 was already 5, but there it is. So minus 5. Okay, so I factored out the greatest common factor, which is always the first step for any single factoring problem. You're going to have a factoring test here coming up soon. Every single problem when you're doing factoring, factor out the greatest common factor as the very first step. Okay, now that I have 4 terms, that indicates, okay, I'm ready to do my factor by grouping. So let's go ahead and divide that in half right there and say, okay, these 2 terms, what can I factor out? Obviously, I can factor out an x to the power of 2 and x to the power of 2 because the lowest power here was this x to the power of 2. Additionally, the coefficients 20 and 24, I could divide by 2, but I think I can go bigger. Can I go 4? Ooh, I could go by 4. Can I go even bigger? Can I go to 8? Can't get to 8. I think 4 is the largest number that I can divide by. 4 and 4. When I factor out that 4x squared, remember that 5 is going to be left over at the very end. But when I factor out that 4x squared, what's left over is a 6x and a positive 5. Again, just remind you, x squared and x squared cancel each other out. 20 divided by 4 is 5. X cubed and x to the power of 2, those subtract and become 1, and 24 divided by 4 is 6. Okay, so far so good. Now let's go ahead and separate the problem and do the second half of the problem. What can I factor out of this one? Nothing. I mean, there's no x here. 6 and 5 are co-prime, so I'm kind of left with this unfortunate place where I'm at a negative 6x and a minus 5 with nothing to do. And you'll see, ooh, that looks similar to that. The only problem is there's, this one has positive and positive. Is there some way I could do something to make this one positive and positive? And the answer is yes. And I'm putting air quotes up again, you could factor out a negative 1. If you factored out a negative 1, then I'd have a negative 1 right here. And I'll have to erase this and this. And I'll say that these are really plus 5. Watch, watch, watch. Okay, negative 6 divided by negative 1 is a 6. Negative 5 divided by negative 1 is a 5. Again, the negative turned into positive, and I switch the signs here by factoring out a negative. This is one of those really key tricks that a lot of students don't see. You have to factor out a negative. And here's another trick that you might need. If you can't factor out anything, just write a plus 1. I can't factor out anything, so I'm going to write a plus 1 or a plus 1. All right, so with that, let's go ahead and end the brackets here. And let's see the groups. The groups are 4x squareds of the 6 minus x minus 5 and -1 of those 6x minus 5. Again, these have to match, otherwise factoring by grouping does not work. Okay, the 5 is still being factored out. I'm not going to touch you. And then what's left over, I have a total of how many of these groups? I have 6x plus 5. So I'm going to write the 6x plus 5. These were the common groups, right? And the number of terms, I have 4x squared minus 1 of those. So I'm going to say 4x squared minus 1 of those 6x plus 5s. And normally, we would be done. Like in the last problem, we were done at this step. However, in this problem, we have to go a step further because this number can be factored even further. You might question how until you remember this is a square. This is a square too. It's 2 to the power 2. And 1 is a square because that's the same thing as 1 squared. This is a square. This is a square. This is a minus sign. This is a difference of squares. A difference of squares always factors to a conjugate pair, meaning we have a 5 here. We have 2 factors. And then we still have, maybe that's not big enough. And then we still have this 6x plus 5. 6x plus 5. Here are the 2 factors. We have a 2x and a minus 1 and a plus 1. Check it out. 2x is the square root of 4x squared, and 1 is the square root of 1. This is your final and very, very complicated answer to your factoring by grouping question. Just be ready that about half of the questions that I'll put on the homework of the test will have this problem where I can factor yet again because it's a difference of squares. And that's not as hard as the ones where you have to factor out, like nothing can be factored out. So remember that you sometimes have to factor out a positive 1. Just be careful. All right, that concludes my 3 examples for lesson 8-5 on factoring by grouping. Thank you for watching.